Hey everybody, Mr. Vandegrassi here, and I wanted to make this video, the first one from our new packet. We're heading into Unit 3, Topic 4 now. You can see we'll be doing the law of sines and the law of cosines. We'll be talking basically forever about how to solve triangles. You can see from the graphic on the front of the packet that, this is going to be a little bit strange. Every once in a while, there might be no solution to a triangle. Often there'll be one solution and one solution only because the triangle is defined uniquely by the given information. But still other times there'll be something called the ambiguous case. The triangle might have two solutions, but we'll get all through that. And not to spoil anything, but there's going to be word problems in this unit too. So we'll be talking about real world situations where, I don't know, a plane is flying and it changes course, and we're wondering how far away is it now from its original destination. You guys can see that would form a triangle, and we're going to need the law of sines, the law of cosines to handle problems like that too. But anyway, these videos are supposed to be short, so I'm going to keep it as short as I can, and off we go. So in lesson 1, let's start by just kind of setting this whole thing up, right? You already know a bunch of trigonometry, at least you should. So going way back in time to geometry, here's a triangle. Now this is a right triangle, so to solve for x should be easy because when you have a right triangle, you're allowed to use SOHCAHTOA. And you might remember SOHCAHTOA is just a mnemonic device that helps you memorize which trig function is which. But looking here, we've got the given angle 40, opposite from that is x, and the hypotenuse is 10. And so SOHCAHTOA tells us that if we want to use 40 in this problem, then we would need to set up a ratio of opposite side and hypotenuse, which you can see as the sine function. So you'd say the sine of 40 is equal to the opposite side, which is x, divided by the hypotenuse, which is 10. And now the algebra to solve is really simple. You just multiply both sides by 10. Those 10s cancel, and you'll find that 10 times the sine of 40 would give you side x. I'm not even going to do that out. 10 sine 40 is a perfectly valid answer. Anyone who wants to hit the buttons can. Now, just drive this point home a little further. Not every question is going to involve sine, of course. So here's another one. Imagine if I gave you this triangle. You would still want to look at it. You would still want to label your sides, figure out who's who. Opposite from 46 is blank, but adjacent to 46 is the 8, and then the hypotenuse is x. So I think a couple of different things will happen here. This time it's not a sine function, it's a cosine function. So we'll say cosine of 46 is equal to 8 over x. So there's another difference. Our variable's in the denominator this time, but no big deal. We could throw this over 1. I usually imagine cross multiplying here. You don't need to do that. You could just imagine multiplying through by x. And that's fine. So now you've got x times the cosine of 46 equals 8. The x's cancel. Now you see that to actually solve for x, you have to divide both sides by cosine 46. So we get x equals 8 divided by cosine 46. So there, that's all. Sometimes these problems are really simple, and you just get a side length times the sine of an angle, whatever. Other times, though, you end up with a side length divided by the cosine of the angle. But if you do those problems the way I just explained, those will be fine. By the way, you're not likely to see a ton of these. We're moving on. Anyway, the setup there is that on the next page, what if I gave you this, and I wanted you to be solving for something, right? If I wanted you to solve for this side over here, well, you don't have a right angle anymore. Right? If you don't have a right angle, then SOHCAHTOA goes out the window. But that's okay, because there's still a way to figure this out. Here's what we could do. We could drop a perpendicular line from here straight down. Because if I drop a perpendicular straight down, well, now I've got right angles again, don't I? So if I was asking you to solve for this side over here, well, it's going to take some doing, but assuming I've got a right angle here, then I can focus my efforts into this right triangle where suddenly SOHCAHTOA trigonometry is allowed again. And what I'll do is I'll solve for this height, right? So we'll say, okay, that height is opposite from the 65. So I'll take the sine of 65, and that'll be equal to the height divided by 12. And I'll multiply by 12. So my height is going to be whatever 12 times the sine of 65 is. And I do have a calculator handy, so 12 times the sine of 65 I can figure out pretty quickly. It's going to be 10.876. Alright, well guess what? Now that I know that height, that kind of bridges the gap over into this other triangle, which is a right triangle. And so now I can solve for x, because now h isn't an unknown anymore. I now know that h is 10.876. So I can set up a new trig equation now. Now I'm noticing this is still opposite from this 42, and this is still my hypotenuse, so it's a sine equation again. The sine of 42 is going to equal 10.876 divided by x. So I multiply by x, I divide by sine 42. X equals 10.876 divided by sine 42. Right. So whatever that is my answer. Let me see. If I take this and I divide it by sine of 42, then I get an answer of 16.253. Okay, fine, I did it, great. So, alright, it turns out maybe I don't need a right triangle. Maybe I can build my own right triangle by dropping an altitude, but then I've got to do two different equations. I've got to solve for some measurement in the middle that I never actually cared about. So I wonder if there's a better way, and of course there is. So I'm going to grab all this, maybe shrink it down, and let's do this again, but this time we're just kind of thinking it through. Here's the situation we just had, right? We had a triangle. In that triangle, we knew two sides. We knew two angles. We knew one side, and we wanted to solve for another side. Well, there's a slightly more efficient way to get there. I still would start this process by dropping an altitude. So I'm still going to do that. Zoop, down that goes. That altitude still represents the height of the triangle, so I'm still going to label it h. But the deal now, again, is focus on those two triangles. In the triangle on the left, we can say that we've got opposite hypotenuse, so we can see that the sine of angle A must be equal to the height divided by side B. And if I multiply both sides by side B, then B sine A is the height. Alright, but hold up. If I hop over to the other triangle, the one on the right, then I could write a different equation to model this height. I could say that this time it's the sine of angle B. That equals the height divided by A. And again, I could multiply by A. So A times the sine of angle B is equal to the height. Now, hold on. If both of these expressions are equal to h, then I can take these two expressions and set them equal. So apparently B times the sine of angle A has to be equal to A times the sine of angle B. And this is exactly where the law of sines comes from. I can now divide both sides by sine A. And if I divide both sides by sine of A, then I get sine of A over A. But I could also divide both sides by B. And so on this side, the b's cancel, and I get a denominator of A. On this side, the a's cancel, I get a denominator of B. And that rule right there is the law of sines. It says that in any triangle, not just right triangles, but any triangle, the sine of an angle divided by the length of the side that's opposite from that angle is going to be equal to the sine of any other angle divided by the side that's opposite from that. So that's the most important thing, is just know that when I call something B, angle B, then the side opposite from that is called side B. A, the angle, has to be opposite from A, the side, but that's it. And I should say, there's nothing sacred here about A and B. If we happened to know the measure of an angle here called C, and we knew the side down here was C, then we could slide that into our little rule too. We could have a third ratio here, where the sine of the third angle divided by the third side would of course be equal to the other two. So any pair of sides and angles this works for. But that's the law of sines. That's sort of how it's derived, and now let's just use it. So here's an example problem. It says, given that in triangle ABC, the measure of angle A is equal to 62, the measure of angle B is equal to 74, and the length of side A, meaning the one that's across from angle A, is 8. Find the measures of all of the remaining sides and angles. So for short, we call that solving the triangle. To solve a triangle means find every single angle measure and every single side measure. So to do this, we'll need the law of sines. I've taken the liberty of drawing this figure for us already. It's going to look like this, okay? So angle A is the 62. I'll mark that A. And so opposite from that, of course, is little a. The 74 is angle B. So across from that comes side B. And then, of course, this angle is angle C. And opposite from that is side C. So we can see that to solve a triangle means to find the measure of angle A, the measure of angle B, the measure of angle C, the length of side A, the length of side B, and the length of side C. So these are all the things I need. Now, you're always going to be given 3 of these things. So really all you have to do is find the other 3. So what do we know? What were we already given? We were given the measure of angle A at 62. So that's already known. The measure of B was given at 74. So that's known. And we were given that side A was 8. So it looks like we have to find on our own B and angle C and side C. Okay, fine. I gotta tell you, the first thing I would do here, I guess, is just solve for the missing angle. Because anytime you've got 2 angles, you can get the third angle for free, because one of the rules you guys have known for the longest time is that all 3 angles of a triangle add up to 180. So we know that to find the measure of angle C, all we got to do is 180 minus the sum of the other 2. So the 62 plus the 74. Yeah, you do need to be showing work for this, even though it's kind of simple. Of course you have to show work to justify your answers. But this would be 180 minus 136. So if you subtract that, you'll be left with angle C, 44. So we can fill that in. All right, that's one measurement down. Just a couple to go. Now to find the rest, this is where we need the law of sines. So the way I think about the law of sines is, you're just always looking to pair things off. So looking here in yellow, I've got angle A and I've got side A too. Anytime I know an angle and the side opposite from it, that's when I know that I can use the law of sines. If I don't have that, if I'm given 3 pieces of information, but I don't have an angle that's opposite from a side where both are known, then I won't be able to use law of sines, and I'll have to use the more complicated law of cosines, which you'll learn about in lesson 3. But I'm good. I can see that I'm going to be able to do it. Looking at the others, I've got this 74, and so I know that the 74 will enable me to solve for side B. And don't forget, we also just found angle C. We just found that to be 44. And so I know that when that angle is 44, that's going to enable me to find side C. And here's how this works. Well, we've got the law of sines, which says that the sine of an angle divided by the opposite side length is equal to the sine of any other angle divided by the opposite side length. So the A's are kind of the key to this problem. They're sort of the linchpin. So I know that angle A is 62, so I'll substitute that in. I know that side A is 8, I'll substitute that in. And so now, because I know angle B, I can say that the sine of 74 divided by side B has to be equal. So I've got myself now a proportion that has only one variable, right? I knew A, and I knew side A, and I knew angle B. That means side B is the only variable left to solve for, and I can solve for it pretty quickly by technically cross-multiplying, I guess. As you get better at this, you'll be able to just do this more efficiently, but I'll cross-multiply, sure. I get B times sine of 62, and that equals 8 times the sine of 74. Alright, from here we see that to solve for B, we just have to divide by sine 62. So B is going to be 8 times the sine of 74 divided by the sine of 62. So there's my exact answer. We are going to want you guys to be able to give this answer exactly, including the two sine expressions. But yeah, we'd want you also to be able to hit the buttons on your calculator and come up with a decimal. So if you still somehow don't have a calculator, you better get one. But we're going to do 8 times the sine of 74. We're going to divide that by the sine of 62. And we get 8.710. And if anybody out there is thinking, don't bother putting the 0 on the end, no, you should bother putting it there. Because if we're rounding to 3 decimal places, and if that third decimal place comes out to be a 0, you leave it in there. It's a sig fig, if you know about sig figs, significant figures. But you're going to leave that in there. So there we go. That's another one for us. We just found 8.710 to be side B. So we've got only one thing left to do. It's solve for side C. And we're going to do it pretty much the same way we just solved for B. In fact, almost exactly the way we solved for B. Right down to the fact that we're still even going to use the same ratio. I'm still going to use sine A over side A. So we'll go sine of A over side A. This time, instead of letting it equal the sine of B over B, we'll let it equal the sine of angle C over side C. And again, both A values are known to us, so we substitute those in. In goes the 62, and we'll divide that by 8. Then, remember when we found side angle C way at the beginning? We'll substitute that in. And now that we've substituted in the sine of 44, we can divide that by the opposite side, which is C. Now we've got an equation that we can solve for C. Alright, so again we could cross multiply. We would get C times sine 62 equals 8 times sine 44. And I'm just going to skip ahead to the good part. We know that when we cross multiply, we're just going to immediately divide by the sine of 62. So that's going to end up in our denominator over here. So we now have our exact expression for the value of C. And we can use our calculators to find an approximate value for C that we round off to 3 decimal places. So it's going to be 8 sine 44 divided by sine 62. And I'm getting 6.294. And if you're not getting 6.294, if you weren't getting 8.710, it is pretty likely that it's because your calculators are still in radian mode. Remember, the 44 and the 62 that we plugged in, those were degree measures. So you need to be in degree mode. You want to be in radian mode when you're plugging in, pi over 6 and 11 pi's over 12s and things like that. But if you get yourself back into degree mode, you should get the same answers I'm getting, which is good. So 6.294 goes here. So we did it. We just solved our first triangle. They gave us 3 of its measurements. We found the other 3, so we now have all 6. So we have solved the triangle. That's it. That's what we'll be doing. Next, there's one for you to try on your own. So I encourage you to do that. Try it on your own. Pause this video right now and do it. And when you're done, you can unpause and I'll throw the answers up on the screen so you'll know if you did it right or wrong. And if you didn't do it right, talk to us tomorrow in class. All right, see you in a second. Okay, by now you should have tried it, and here's what you should have gotten, I hope. I would start by solving for the measure of angle D. Here's my drawing, by the way. You should sketch this thing out. If you're worried about drawing it accurately, don't be worried. I always just draw a triangle that's basically like an equilateral triangle. And it doesn't matter that my 34 actually looks like it's bigger than the 76. It doesn't matter. You're just trying to get the lay of the land. Anyway, when you do the math here, you get 70. Hopefully you got the same. Now that you've got 70, you can set yourself up a ratio where now that you know the 70, you can say sine of 70 divided by 9 is equal to the sine of either one. You can pick either one. I chose to solve for E first, but we could have solved for F first. So sine 70 over 9 equals sine 76 over E. Again, we cross multiply, we do our thing. I found E to be 9.293. And finally, we'll do the same thing for F. I'm going to stick with my 70 and my 9. My 70 and my 9 are the ones I'm really confident about. So I'll say sine 70 over 9 equals sine of 34 divided by F. And again, cross multiply, you should find that F is 5.356. And that's it. That's law of sines. Pretty simple. Alright, so anyway, you'll have a bunch of practice in class tomorrow. If you guys are confused, we'll help you out. And then it's on to lesson 2. Thanks for watching.